Hello, everyone. In the last class, we have discussed how to calculate the average precipitation of any given station. So, the next is there were three types here. We have already discussed this earlier. That is three methods to find the average annual rainfall, depth of the rainfall. Okay, so that was arithmetic average method, Thiessen polygon method, and next is isohydral method. In today's class, we'll be solving problems on these methods. Okay, the problems are quite simple. Okay, so you can see here in this first problem, point rainfall due to the storm at several rain gauge stations in a basin are tabulated below. Determine the mean depth of rainfall over a basin by Thiessen polygon method. So in this, there is a Thiessen polygon method. They asked you to solve this by Thiessen polygon method. They have given you the average. They've given rainfall station. So rainfall stations are P1, P2, P3, P4, P5, and P6, P7. So there are seven stations. And the observed precipitation, this is in centimeters. That is 130, 100, 160, 50, 90, 70, and 90. Okay. Then the area of the polygon influenced by the rainfall station is also given. Now this area and see here this area, whether it is in kilometer or meter, keep it as it is. Ultimately, what we need here is this precipitation. Okay. So precipitation should always be in centimeter. Precipitation should be in centimeter. Okay, so now first use the formula average depth of the rainfall. So average depth of the rainfall here, because it is a Thiessen polygon method. So average depth of the rainfall is A1, P1, A2, P2, A3, P3, A4, P4, A5, P5, A6, P6, A7, P7. Because there are seven precipitations, seven rainfall stations divided by A. A is the total area. Okay, next, once you write the formula, next is just substitution. So it is 130 into 0.05. Go on multiplying this 100 into this column into this row. Okay, this row into this row. So go on up till this seven stations. So once you, and be careful when you're solving this. So this should be, please use brackets. Okay, so if you use brackets, it becomes simpler. So okay, so once you write this, solve this, so the total A into P values will be 3471.5 divided by 24.8. So now this is in terms of centimeters, because the area is in centimeter. So it is like this is precipitation centimeter into centimeter square. Okay, so area will be in centimeter square. So square will cancel and you're left with only centimeters. So now the total average depth of rainfall is 139.98 centimeters. So this is using the Thiessen polygon method. Okay. Okay. Next problem is the ISO heights due to a storm in a catchment were drawn, and area of the catchment bounded by the ISO heights which are tabulated as below. Estimate the average depth of rainfall due to the storm. So again, in the given problem, they have given you the data in terms of ISO heights. So ISO heights are nothing but they are given here. Areas of the isoids are nothing but they are imaginary lines on the map which provide the same depth of the rainfall. Okay, all right. So you can see here these are ISO heights and this is area in kilometer square. Okay, so these are ISO heights. They've given you the range 80 to 100 up to 190, and simultaneously they have given you the area here also. Okay, so now if you're using this iso heights method, so according to the formula, it is average depth of the rainfall using iso heights method is 1 divided by A. So it is 1 divided by total area into summation of area between the two adjacent iso heights into mean two adjacent iso height values. Okay, so area between the iso heights into its mean of the iso heights value, adjacent iso heights. So it is more specifically, you can use it in the column only. So you can solve it here only. So isohydrate's range is given. So first is 80, next is 100. So 80 plus 100 divided by 2, because we want the average or mean of the isohydrates. So 80 into 100 divided by 2, 90. Likewise, 100. The first is 100 plus 120 divided by 2. 120 plus 40 divided by 2. So go on doing this. So ultimately, you want the average of this. Once you get the average of the isohydrates, then area is already given here. Okay, 9.3. And now go on multiplying this. 90 into 9.3. Okay. Similarly, 60 into 6.95. 6.95 into 110. So go on multiplying this. Okay. So ultimately, you'll get this answer. That is, total area is in kilometer. Okay. So now you can see here, again, don't convert any values here. Just keep it in centimeter, keep this in kilometers only. Okay. So it is like when you multiply this, see here, this is 24.80 kilometers square. So area is in terms of kilometer square, and this product, now this product 29 2914 will be in centimeter kilometer square. Okay, this is centimeter kilometer square. So ultimately here, this is the, in this numerator, the unit is centimeter. Precipitation is centimeter into kilometer square, right? So divided by kilometer square. So kilometer square will cancel. So you're left with only centimeter. So this is now average depth of the rainfall is just 117.52 centimeters. Always try to keep it in centimeter or mm, the precipitations. Okay, so the next problem is calculate the mean aerial rainfall using isohydral method. Taken the Take the necessary data from the given figure. Okay, so again here they have given in the form of diagram now. So earlier it was they had given in the form of column, tabular column. So it was little easy. Next thing is for this you have to tabulate a column. That's all. They've given you the figure. So you can see here this is A, B, C, D, and E. So this is the first iso height 50, second iso height 70, 90, and 110. Okay. So now, once you get this, next is put it in the column. Okay, tabular column. The same diagram, put it in the tabular column. So write the zones here. Zone 1, 2, 3, 4, 5. So total 5 zones, and iso heights. So iso heights range is given. So within, see here, this area is lesser than 50. Right? This area is lesser than 50. So write the iso height less than 50. Next, 50 to 70 is 1, 70 to 90 is 1, 90 to 110 is another, and after 110 it is like greater than 110. You can write here greater than 110. Okay, so now next mean isotype. So mean isotype here is less than 50. So you can take this as range 40 to 50. So mean of that is 45. Then 50, 70, 60. Here it is 80. Here it is 110. And this is like greater than 110. Okay, so it is like greater than 110. Now you don't know how much range to be taken. So we have assumed it to be 95. Okay, next is once you get mean, next is area. You've already got the area here. Area is already on 25, 60, 80, 80, and 55. So write this like this. So total area. Now add this. So total area is 300 kilometers square, and average precipitation is multiply both P into A. So P into A will give you this value. 60 into 60, this value. So go on multiplying. 100 into 80, 8,000. 95 into 55, 5255. So we got the average precipitation. So next is average depth of the rainfall is given by, okay, total, this value, okay, divided by 300. So 24350. Okay, 24350 divided by 300 is the total area. So again, same thing here also. You can notice. So this is average precipitation. This value is P into A. P is in terms of mm, right? P is in terms of mm. Okay, so it is like mm into kilometer square divided by kilometer square. So mm into kilometer square divided by kilometer square. So this would be, so 24350 divided by 300 would be 81.66. Oh, here is a necessary correction here because 81.66 is not in centimeter. See here, this is given in terms of mm. So you have to write this in terms of mm. So this would be mm. So P is in mm. So mm kilometer square divided by kilometer square. So kilometer square will cancel. So you're left with 81.16 mm, or it would be 8.11 centimeters. All right. Okay. So these are the three types of problems based on the uh, three theoretical concept to calculate the average annual rainfall. All right. Okay. That's all for today. Thank you.